Check. Check, check. Check, check. Check, check. I think I heard it. Okay. Should be good. I've been really lazy. I haven't made any new video music yet. Okay, let me also sure I don't forget to called in where are we at? Appearance. Go. Still can't understand why in regular OBS I can see the chat, I just can't see how many people there are. Gotta keep using my phone. Annoying. Okay, just gonna keep working on this distortion. Where are we at right now? Let's see here. Before I explain, well, I mean, people are gonna watch. Okay, so and if people jump in and they ask, I'll just go over it again. So I've got 1, 2, 3, 4, 5 distortion algorithms in this plugin. Right now, not using a GUI. I'm using like the Juice auto-generated generic. Show you real quick. Check. I have no idea how long the mic was out, but I've got 5 distortion and they sound all right. I had an error that I didn't realize. I was testing them on the song and Logic, and I was testing it on my guitar input, which were mono channels going to stereo, like because it was a mono track in Logic, but it was going to the track stack. And I didn't realize the plugin wasn't handling mono to stereo, so I had to add this line in here where if total number input channels is 1 and the total number output channels is 2, then we just copy the left to the right. I also changed the layout to this. It's just, I don't understand why the default one looks so complicated with all the macros and stuff. I just changed it to this. And did I change the input at the top? Yeah, I just put it as stereo for both. That seems to work. So all that to say that my distortion algorithms are decent. They just need to adjust the volumes. And I'm also gonna make it to where this plugin works well when your input is at negative 18 dB. So basically what I did was, assuming somebody has their track at negative 18 or around there, just multiplying the input by 18 and then pulling down, multiplying by 18 dB and then pulling it down on the output by 18. And that seems to work. I need to do a couple of things. So this is the overdrive. So this is kind of like a tube screamer. Let's see what I did. I've got a high pass filter at 300. A lot of times the schematics say that the high pass filter in a overdrive is around 700, and I did that and it just didn't sound right. Like it was cutting too much of the lows out, and this sounded fine. The low pass filter also, it could be anywhere between uh basically like 1000 and 3000 hertz for the low pass filter. And I just went with 3500 because I think that's what the actual schematic for the tube screamer was. Can't remember. And then I've got some DC filters because I'm using to do the wave shaping, I'm using half of the Paletti amp. So getting just the basic distortion shape without the crossover distortion and stuff, which if you look at the output of any distortion pedals, or not distortion, but like any overdrive pedals, there's no crossover distortion. It was just like a simple regular wave shaper, so I went with that. And we've got a tone filter at 800, so that's pushing into the distortion, which gives you that typical kind of like hard like push into the distortion, and it gives you like a lot of clarity and punch and a lot of staccato. So I've got that. So we'll put the tone before the distortion, and then put let's see. Here's the, oh yeah, the low pass and high pass is handled in the broader distortion class because it doesn't need to be different between each one. So I think go here. Let's see. And then here we go. Oh, it must be in process block. Okay. Yeah, so process block. Yeah, okay. So we've got the filters, the high pass and low pass filters before the distortion. I've also got this rip mode, which is like the push, like on, or it's called push. I don't remember what it's called. You go, it's called punish. Yeah. So for theirs, I think they said the punish was an added 18 dB on the input. I put 10 for mine just to try it out to make sure it worked. It seems fine. I don't know if I need to push it that much, but also if you go to the JST clip plugin, it also has a similar function. It's got called 2 times. So yeah, just, you know, that functionality. And then when you do that push, since this is called the ripper, I'm calling this rip. And so you multiply it by 10 and then bring it down by 10. So easy. So let's see what we got here. I guess we need to check our volume. So I guess let's build, and then we'll check it out in Plugin Doctor and see what we've got. Okay, built. Okay. So let's see what we got here. Here's the ripper. Oh, I also did this other cool thing. So I put, if we go into distortion, before each of the distortions, I put some pink noise. So basically I just took white noise and put a low pass filter on it around, let's see, 1000 hertz. And it actually does make a difference. Even, I feel like it makes the distortion a little more lively and not so static. Like static in the sense of like, I don't know, like, you know, like sterile and just kind of linear. Like I feel like it has a little bit of movement and has a little bit more life to it. You don't really hear the noise, especially with the filter. So that's cool. Another thing I did is the tone filter. So I have this tilt EQ, and that's what the tone is basically. the overdrive, the tone is just a peak, but everything else has this tilt filter. And what I'm doing is I have a LFO that changes the cutoff point of the filter and the gain, so that it's kind of moving between, it's slowly moving between a cutoff of 1,000 and like 1,200. So it's kind of like very slowly drifting, which hardware does. And then the gain is drifting up and down for each side by what would that be, like 0.2 dB, I guess. And can we actually see it if we go to class B amp and we do the tone? It's really hard to, it'll probably be even harder for you all to see the video, but the cutoff is moving very slowly left and right, and then it's kind of bouncing up and down a little bit. So that just gives it an extra layer of life that isn't, you know, an LFO isn't a big deal in terms of like CPU. So, I mean, you can throw it on anything. So that's that. Let me turn the tone back down. Alt. So let's go to overdrive. What's our volume look like? It's really high, but that's kind of expected. For example, we go and get something like, does this load that free? Yeah, it doesn't. If we load, like I've got audio assaults amp blocker, I'm just going to turn the amp off, the cab off. And I'm not trying to like match their plugin or anything. I'm just trying to show you what is kind of expected for anything else. We do have some gain boost. I think that might, I don't really know what that is, but I'll grab their overdrive, the HyperX. So you can see it's pretty loud. This is kind of the shape. So it also gets kind of loud. And if I go back, yeah, okay. So if I go back to the regular scaling, you can see that it's pretty loud. And the shape, actually, now that I think about it, isn't that unlike mine, which is kind of cool. Go to overdrive. Yeah, it's pretty similar. I do have this weird little, oh, I guess I have a much bigger tone than, yeah, that's what it is. But yeah, so we can see that we've got a real heavy peaking here at like 800 hertz. That's probably too much. We're gonna need to turn that down. Let's see. Let's do how should we do? Got the overdrive, and we've got oh, I've also done this. This might be really helpful. I've made an interface basically for the distortion. So I have this base distortion class that each one inherits from. So I took all the stuff that I was copying between classes, like the drive and the mix and the tone, and put it in here. Also all of the smoothers, like the drives and the inputs. So now in each instance, instead of having all that stuff in there, we can just call get input comp, get output comp, wherever it is. Probably not in here. And what else? Things that aren't shared still have to be put in here. So I needed like the extra DC filters, and I needed the specific high pass and low pass. I'm basically re-implementing set drive and set mix for each one, because sometimes they will have like an extra multiplier or something. So yeah, that's it. Just a little helpful interface. And let's see, what do we have to do? Tone, this tone. Ah, it's the peak plus 10. Okay, so maybe we could do like 3 instead. And Do we have anything else? We could, well, let's just build it and then listen to it. check. I have no idea why that keeps happening. Like OBS's audio input capture, it just stops for some. But yeah, so I have a whole playlist on my YouTube of like, I don't know, 6 to 8 videos or something of you know, a basic walkthrough of everything you need to do to create a plugin. As an example, setting up Juice on a computer. I think also like setting up Xcode and also Visual Studio. And yeah. So it's kind of presented in a way that you already have some coding ability, but even if you don't, I think you could follow along and pause the video and copy and paste stuff and you know, match what I do exactly, and you'll have a working example and you'll be able to do your own work in it and eventually start to understand it and stuff. So I have a bunch of videos of just me working on things, so hopefully there's enough there to get you started. I also recently uploaded a video of setting up CMake on your computer. It's just a more modern way to work with C++ projects. And yeah, I guess I could make some new kind of, I could remake all of those Juice tutorials, but nothing's really changed that much. So really, I mean, the only change I make is using CMake now. But yeah, I also have, I mean, I think I almost have 100 videos now, so it's just me working on stuff. So yeah. So what I'm making now is basically just like a free version of Decapitator. And sounds all right. The overdrive is good. Let me also check the other models to see how their volumes are. So like we've got so the class B amp, which is the Paletti thing. That looks fine. I'm kind of on the fence about whether I want to put output gain on there by default or just let the user pull down the output knob when they need to. I don't know. I don't usually like automatic gain that often. So here's the tube. Let's see. That should be fine. Okay. Here's the circle map thing. Yeah, these are fine. Okay, and then the tape should probably be fine. The tape has a little bit of compression on it. Okay. All right, let's listen to them. Sure, they still sound all right. Okay, I guess let's do maybe the drums. Just check all the other models. Let's. Yeah, they're around -18. Okay, so let's see what it sounds like. The signal around -18. Okay, cool. I still have to fix the tube. There's some kind of small mistake in there. Because I hear a rattle. I think the circle map one is like the coolest one. I think that's good for like a console sound. And if we turn the mix down. Oh, the drive is affecting the. Wait, why is the drive was affecting the input, the dry input? Okay, I got a mistake in that one, so we'll have to look at it. But okay, how about the tape? Okay, cool. So they all sound good on your input being -18, but that's good. Let's look at that. Oh, also, does this one have the same issue? No. Okay, so it's just the circle map one. Yeah. Okay, let's go take a look at that real quick. So mix samples xn. That's why, because instead of xn, we just got to pass in data sample directly, and that'll fix it. Okay, so what else do we want? So we got, I don't know what we're gonna call the circle map one, but we've got a tube, got an amp, we got an overdrive, we got a tape. I might call this console. So that's 5. I wasn't sure exactly how many I wanted. I think Decapitator has 5 or 6. I was kind of wanting to do like 10, but kind of a lot. Let me look in the book right here. So we've done the tube. Oh yeah, he has the valve pair, which is great. There's 2 of them in front of each other. The first one takes the drive input. There's a big muff. I'm not really super into that on this kind of plugin. It needs to be just like a somewhat, I don't even know the right word, normal distortion. Turbo distortion. What's that supposed to be? Is that based on a pedal? Probably. It's probably listed earlier in the paper. Okay, we got a slope. Sample. Okay, it's just a tan. Just that basic tan. Shaper thing. Oh, he's got like a Mark 1 amp. Looks like it's just using a combination of the other wave shapers he's written for previous models. Wicker amp, that's interesting. Oh, we could do a bit reduction. That's really easy. I already have that written somewhere. I'm interested in this wicker amp though. So it's using tubes. Huh. Got, where's the actual? Give me the code. I guess it's not. Unless I'm stupid and I just skipped it. I think maybe actual DSP for the wave shaping and stuff is probably just inside of the code that goes along with it. I don't even know where that's at or whatever, but Okay. So maybe we'll do a bit reduction. No resampling, probably just like a bit reduction. So yeah. Header file. Or bit reduce. Progma once. And let's go here. Okay. Let's, it's pretty simple. We could probably use this. All right. Yep. Reuse the circle map one. And we'll just call it producer. Okay. This isn't difficult, and I already have this code somewhere. Let me think real quick. Yeah, yeah, if I open the other one, what I do? Okay. Okay, so I'm not gonna do the resample rate thing. I think I just want the bit depth. So, what do we need? All right, let's start at least with the filters. So we're gonna need two low passes. We can steal this right here. And these are called approximative filters. I'm just gonna call them filters. And okay. Oh, wrong. Go. Start with process code. Okay. All right, so I'm just gonna copy this. We're gonna see what we need and don't need. Gonna so let's see. First skip sample. I don't think we need the Q levels, less quantize. Okay. So let's pull these things that we need. We know for sure we can do this. Okay. And we'll need very least we need our bit depth, and I don't think we need to make it a smooth value because it's in, oh, it is float. Yeah, okay, let's see how it sounds first. We might not need to do a smooth value. Okay, downsample counters. This is gonna be, yep, vectors. Okay. And we'll do equal output. Okay. Fine. Okay. And then we need to initialize the vectors, I'm sure, at the top somewhere. Yeah. Okay. That's that. Okay, let's grab this set bit depth. Probably the last thing we need. Okay, so this is gonna be let's see here. Oh yeah, I got the limits for the new bit depth, and I think that was just something I experimented with and found good values for. Yeah, okay. Okay, that's easy. What we'll do is okay, so what we'll do is inside of distortion, inside of set drive. Oh wait, we didn't actually make a member. The bit reducer. Let's take bit reducer. Of course, we have to prepare it. And in here, we're going to do set drive, but what we're going to do is this really is going to be the bit depth. So our drive is from 0 to 30. So we can do const auto bit depth is equal to juice jmap. So we'll take new drive, which is from 0 to 30, and we'll make that 16 to 2. So that when the drive is 0, we'll have no bit reduction. It'll be at 16 bits, and then when the drive is all the way up, it'll be 2 bits. Yeah, that should work. So, oh, but we'll call it. We need to do this instead. That bit depth. So we need to make another. Yeah, we need to add a reducer here, a bit reducer. Bit reducer. And then in here, that, and then reducer process. Let's do the mix. So we've got we don't need the drive for this one. So let's do the mix. This is gonna be the Tor DSP utils called mix samples. So your dry, which is data sample, and the wet, which is output, and then the right. Yep. Yes. Okay. Good. All right. So the mix is there. Probably we don't need to do anything in that drive. Okay. Might be it. We need to also add it in our global so that it knows we have another one. Where does it go? I already forgot. Here. Okay. And I think that's it. Let's see that choice. Oh, we got 3 in the chat. Feel free to stop me at any time if you want me to explain something. Check. All right, so if we go bit reduce, okay. Oh yeah, it's changing. Okay, and it's supposedly processing, so did something wrong. Maybe yeah, I couldn't remove those. Unless did I miss another process sample? No, that should be fine. Okay, so maybe I do need the resampled math. I didn't think it was necessary. Put that there, and then and also need that. That. And what we'll do is sample rate will be inspect dot rate and resampled. I forgot how the resampled rate worked in the other plugin. What did I do? It was between 0 and 100. What's the resampled upper and lower limit? The lower limit. Sampled rate is equal. Okay, so we're saying PAL of the safe rate 0 to 100. So it's 0 to 1. Okay. And which is from 0 to 1. Make it from sample rate to. Okay, so I think we just give it, if we want it to do no resampling, I think we just give it rate again. And right now. Everything else good? Okay, well, I don't know. All right. Doing anything. Sure. I'm sure I'm just making some kind of dumb mistake that I'm not seeing. How does your seat look like that? What do you mean? Like the colors? App icon. You mean right here in the dock? I'm not sure. I don't I don't know what it's supposed to look like. I mean, the OS version I'm on is Sonoma 14.4. I don't know if that's it. Also, I did update Sea Lion. Yours is blue, pink, and green. I mean, mine is too. It's just probably in different areas. Wait, let me look at the stream. Oh, I guess that is accurate. I don't know. I mean, I did update it recently, so I don't, maybe that did it. Okay, definitely got that. We got go. Definitely working because I had the debug statement. Bit depth was changing. So what? Here's the first question: am I sure that this code works? I guess uh the other thing I could try is I don't know the correct value for this. I'm gonna see if I can do a live constant, change that in real time and see if that fixes it. Because I might just be putting the wrong value. Okay, let's see if that makes it. Look at the scope. The bit reduction all the way up. Okay, so right now this is 1. Now that's not doing anything. That's super surprising that that's not doing anything. Yeah, return output. Output should be the. What does my resampled rate start at? 100. So this would be sample rate divided by 100. That would be like 44.1. 440. So let's quantize total level. That should be like, I mean, this is really the bit reduction part right here. So we put that into last quantized. Okay, so then output is equal to last quantized. We don't need this. We don't need that, and we need this. Let's check. We could check what this is. I'll just say out. See what kind of values we're getting. I would expect these values to be like, they should be rounded sample values. So like, they should be things like 0.1, 0.4, 0.04. They should be rounded to very to like tens, hundreds, and thousands. So we probably shouldn't get something like 0, 5, 6, 8, 7, 7, whatever as a value. Oh, I know what's happening. We're not pushing anything to downsampled counters. So if we're not advancing it, it's only going to run this one. So downsample count plus one. Okay, I don't know why that wouldn't. Oh, I'm stupid. Hold on, I messed this up. And worst comes to worst, I'll get the hack audio book because there's a very simple, like a bit reduction example in there. Since we, what is this nonsense? This is what happened to my other plugin. Something just happened. What I'll do. Oh, because I tried to build the wrong one. Yeah, this one. Okay. All right, so we're getting. Okay. From that output, it seems like it should work. I don't know. One thing we definitely have to. Let me grab that book. Hack audio. Hack Audio by Eric Tarr. This is the best beginner DSP book I've ever seen. All right, so we're going to get rid of everything. Here. All right, so he's got distortion, he's got all kind of great stuff. He's got start at the beginning of this part. Okay. Starts with total harmonic distortion. Then he goes into infinite clipping. And then rectification, so half wave rectification, full wave rectification, which is important for amp modeling. Got hard clipping, he's got soft clipping. He's got a bunch of different soft shapes, so like the arctan distortion, cubic, a power series distortion, exponential soft clipping, and piecewise, overdrive, and then here we go, bit reduction. And it's actually really simple. It's 1, 2, 3, 4, 5, 6, 7 lines. Okay, so I'm just gonna write exactly what he did and just see how it comes out. So we make a make a variable called const auto. I'll call it m amp values, and this is gonna be 2 to the power of your possible bit depth. So we'll do PAL, and we'll do 2, I guess, to 16. Okay. So first thing he does, I'm sorry, const float. First thing he does is reduce the input by a bit. So we'll do xn times equal 0.5 plus 0.5. So he says shrink the full scale signal to fit within a range of 0 to 1 instead of -1 to 1. Okay. And then so what we'll do is take const out so that we can do that in. And then what we'll do is create our yn right here, which is going to be xn times the amp values thing. So what did I call that? I already forgot. amp value. Okay. And then we'll say, let's not make it const because we're going to do more operations on it. Yep. And we're going to say yn, equal to std round yn. Then he'll do yn divides equals amp values. And then we got to put it back into the full scale. So we'll say yn times equal to +1 to get it back to -1 to 1. Okay. Okay, so does that mean that I would instead do okay, let's just send that out and see what happens. And what I'll do probably, I'm thinking what will happen is this will just statically be 16. So let me set this down to like 4 and see if that works. And if that works, then we know we can just replace this with our bit depth variable. And this is the best time to use Plugin Doctor to test it so that you don't blow your ears up with a DC offset in logic of like 10,000 dB. Oh, here, oh, looks crazy. It doesn't look, yeah, okay. That's, not right. Let's see. So I don't think this is making a difference, but I am going to take this input out for now. Trying to make sure I didn't. Okay, nonlinear processing to be possible amplitude values for. Oh, I think. Okay, I think what we actually need to do is this. I think we need to do So this will be based on the bit depth. Okay, and then when we go to use amp values right there, values right there. I think that's more correct. Okay. Could also be, so his examples from this book are using MATLAB, and it's possible that the MATLAB round and the C++ round is very different. So oh, it might be working. Okay. Oh, oh. Certainly seems like it's working. What oscilloscope? Is it loud? Oh, okay, it's up there. Okay, yeah. So what I'm thinking. Okay, so there we go. That's the bit reduction. So I'm thinking we can't use his math. We need to, what is this? Yeah, I think his math is unnecessary for us in terms of shifting it around. So if we, yeah, I don't remember doing that at all. So what if we don't do that and we don't do that? Yeah. Okay, cool. The only thing is that between 16 and like, I guess, 2/3 of it. So I don't know, between 16 and like 8 maybe, or like 16 and 10, there's not much of a difference. So let's just go listen to it and make sure. So yeah, we can get rid of this. So here's your bit reduction algorithms, literally 4 lines. So that's cool. And while we're here, let's yeah, let's do our mix, and we can listen and see if it sounds cool or not. Mix, so data sample, which is our dry, YN, and we probably have to go all that mix for our, and you know what, this is really dumb. This is super unnecessary. So let's do this. Let's see, we can, yeah, let's yeah, we can do a vector, or I'm sorry, a vector of base distortion. So distortion, and we could do something like this. We could go into the constructor Might as well clear it to start. Don't know if it's necessary. We do this dot in place back. Oh, we need to do I'm sorry, we gotta do this. Instead of pointers like that, we can do unique pointer like that. And then in place back, and that would be std make unique editor PSP. What's the first one? Class B amp. And then we can just leave it like that. We don't need a object input. Let's just do this. How many are there? 6. Class B, Class A valve, circle map, tape, overdrive, okay, and now we can just auto distortion in, what did I even call them? Distortions, distortion pair, spec, get rid of this. And then we're going to do something similar, but we need an enum first. So we need enum type. Oh, call it type. Okay, so first one's amp. That, and then circle map, and tape, then overdrive, then bit reducer, and then I don't know if we'll need it, but we'll make a num portions in case. Cool. So then we could do this. We could do distortions right here. A class B amp. That work. What's your problem? Is C line just being slow, or no member name process in? Oh yeah, okay. So I think let's do this. Virtual void process, which takes in a block. And like that. And then we go into each one for their process method, and we say override. the beauty of C++. Okie dokie. Virtual function not implemented. Yeah, no, it's not. Okay, does that work? Yes. All right, so now we can do this. Boom. Boom. Okay. Class valve, and then I think it was the circle map. And then it's tape. Overdrive. And bit reducer. And now we can do this. So we can reuse the loop. Do this. Distortion. Set drive. And we'll take the ones that are different and do them after. So this would be distortions. Oh, which one was that? I forgot. That was the valve. Okay. So this will be valve. That. And then so the bit reducer for this one. Oh, this one, yeah, so what we're gonna do is we're gonna say if this, and I know this is like verbose and kind of dumb, but it makes the rest of the class simpler. So what you do is the base class, which is what's in this vector, doesn't have set bit depth, even though the member itself has it. So we have to cast from this to the actual member that it is, and then we can use the set bit depth. So this is going to be if auto distortion is equal to dynamic cast to toward DSP bit reducer pointer. We pass it the base class, and we say dot get, and then now we can say distortion dot set bit depth. Okay, and we don't need to check if it's null or not, because this, we're doing it all in the if statement itself, so that should be fine. And then we just need to do the mixes. Okay, and the tones. Set tone, but one of them just says set deep. And that's the overdrive. Okay, so we'll do the same thing here. So this will be the overdrive one. This will be set. Okay, so we can get rid of that. Okay, and now when we add a new thing, we add it here, here, and we also have to do it here, but we've reduced it by the prepare one, the drive one, unless we have a specific one that we need to do, and then a mix in the tone. So, okay, we cleaned it up a little bit. So it's a little more more good, I guess. Okay, so that's that, and now I guess we could see if it still works. Trying to, when I notice really dumb code, fix it so that I don't turn into a pirate software situation. All right, let's see if it still works. Oh, oh, not looking good. Crash immediately. Um, let's I assume it's gonna crash. Well, so let's see if we can get it to crash in debug mode. Maybe everything I just did won't work. That'd be funny. Oh, well, certainly didn't break here. Okay, I'll read this. It doesn't like something about the base portion. I'm not sure what it doesn't like. Construct at so let me take, I guess up to, we'll pull out the ultimate weapon. Okay. Here's a crash portion. Plugin. Here it is. Let's might be something simple. Thinking longer for a bit. I will see. We'll see. Oh, the crash was in the destructor. Okay, so maybe it's because I don't have one. But why would the destructor be called loading the plugin? Um, I guess should define a destructor. Bro, that's already taken. So probably just need to make a destructor for. Okay. We'll see. Don't know why that would be a thing. I wouldn't think that the destructor would be called until I close it. Oh, it might try to verify. It might do a quick verify, and it might call the constructors and destructors and stuff. So maybe it's crashing. Yeah, okay, that might. All right, let's see. Nice. What does the mix work too? Yeah, that could end up being interesting. Honestly, yeah, that's a hmm. What I'm thinking is because the drive is so weird, where the first half of it isn't much of a difference, which we could fix with like some kind of nonlinear function. But it seems to me that we could set the distortion to always be this much, and we can make the drive knob actually the mix, so that when the drive is 0, it looks like this, and then as you drive it, it gets, because that's more smoother. So then the only bad thing is, I guess the mix won't really do anything. See what it sounds like. Check. Okay. Bro, again. That's strange. I think it's probably just what is, oh yeah, it's because the circle map doesn't use a DB. Yeah. Converted. Okay, now okay, that's good enough for now. So we've got the 6 models. Okay. Might be able to come up with a few more. All right, but that's good for tonight. All right, cool. Thanks for watching. Here are my Patreon subscribers. Subscribe to me there. If you want to support me building more plugins. I'm gonna be releasing this one for free whenever it's done. So I don't know, probably a couple weeks, something like that. So yeah, I stream on Monday, Wednesdays, and Fridays. Join the Discord from the video description, and that'll be it. All right.